simple and compound interest. A warm-up. Pause this slideshow and calculate these percentages. Now remember, when we're multiplying by percentage, we first need to change it to a decimal by dividing by 100. Then we multiply by our amount. Here are the answers for you to check. How'd you go? Simple interest. When you deposit money in a savings account, your deposit is called a principal. The bank takes that money and invests it, and in return pays you interest based on the interest rate. Simple interest is interest paid only on the principal. Simple interest has a formula, SI equals PRT, where P is the principal, R is the interest rate per year as a decimal, and T is the time in years. In the real world, suppose that you deposit $400 in a savings account and the interest rate is 5% per year. Find the interest rate earned in 4 years. Find the total of principal plus interest. So we have our formula, interest equals PRT. We have our values, principal is 400, interest rate as a decimal, 0.05, and the term is 4 years. That calculates as $20 interest on 1 year, so in 4 years, that's $80 interest, and that gives us a total in the account of $480 after 4 years. Try these. Find the simple interest. This first example is for 3 years. The second one is only for 6 months. So you'll need to make the year component in the formula, the T, a fraction of a year. In this case, half a year. Here is the answers. First one is $30 interest earned on 3 years on $250. The same $250 in 6 months at 3.5% would earn $4.38. Compound interest. Compound interest is when the bank pays you interest on the principal and the interest that's already been earned. And so as the name implies, it builds and grows a lot quicker. The balance at the end of each period is the principal plus the interest that has been earned in that period. The balance becomes the principal for the next interest period, for the next calculation. An example. We deposit $400 again, like before, for 5% 4 years, and it's compounded annually, which means once per year. In this example, you could pause and work ahead, or you could work along with me. So we're going to calculate the compound interest, but we're going to do it in parts using our simple interest formula. Now, how we do this is we use the simple interest formula for each year. So in each case we do this, the T value for our formula will be 1 because we're just doing it for that 1 year. So first up, year 1, we have $400 principal. Interest rate for this example is going to be 0.05, 5% as a decimal. So that gives us an interest amount of $20 in the first year, and so balance at the end of the year, $420. Now that balance will become our principal for the beginning of the second year. And so in the second year, because we started with a higher principal, we have a slightly higher interest payment for that year. So now our new total at the end of the second year, $441. Bring that balance forward for our principal at the beginning of the third year. The third year, principal 441 times the interest rate 0.05. We have an interest payment of $22.05. Add that on to our previous balance, and we have a new balance for the end of the third year. Now we carry that forward for the fourth year to work out the final year. And so we have a final component, $486.20, which is slightly different from if we just used the simple interest formula for the whole 4 years. We would have had only $80 interest total, so it would have been a total of $480. We have a compound interest formula so that we can do this in one step. The interest period is the length of time over which the interest is calculated. The interest period can be a year or less than a year. Here's our compound interest formula. A is the amount or the final balance. B is the principal from the starting point. R is our interest rate, again as a decimal, and N the number of interest periods. So if we use our example from before, where we had principal $400, put that into our formula, an interest rate of 5%, so 0.05 into our formula, and the number of periods was 4. It's 4 years in this case. So then we can calculate that in steps using a calculator, and we see that we end up with the same total as we did using the simple interest formula in repeated stages. Semi-annual is when we have 2 interest periods in 1 year. So each interest period would be 6 months long. When we have a problem with a semi-annual interest period, then we need to divide the annual interest period by 2. So if we had a 6% annual interest rate divided by 2 interest periods, we'd end up with 3% semi-annual interest rate. Now to find the number of payment periods, we multiply the number of years by the number of interest periods. Here's an example. Find the balance on a deposit of $1,000 earning 6% interest compounded semi-annually for 5 years. The interest rate for compounding semi-annually will be half of 6% as a decimal, which will be 0.03. And the number of payment periods will be the number of years multiplied by the number of payment periods. And that will give us 10 periods. Now we just plug that into our formula. Here's the formula. So to substitute the principal, $1,000, and the interest rate, remember for the half year is 0.03, and the power of n is the 10 periods that we calculated on the page before. Again, step by step with the calculator, and brings us to our final amount. And remember, we'll always round off an amount to 2 decimal places or to the nearest cent. So try these. Find the balance for each account. So the amount deposited is $900. The annual interest rate is 2%. Note that's an annual interest rate. And the time is 3 years. Do it first time when it's compounding annually, using the interest rate as is and the time period of 3 years, and then do it for compounding semi-annually. So pause this slideshow now while you can work these out. Right, now I'll give you the answers so you can check. So the first one, the total amount at the end will be $955.09, meaning that the interest amount was $55.09. And the compounding semi-annually example, you ready? The amount there is $955.37. Doesn't sound a lot of difference, but remember, we're only investing $900 in this case. When you're investing bigger amounts of money for a longer period of time, the difference with a shorter compounding period really makes a difference. Thank you. I hope this helps.